Hello, everybody. I'm glad you could join me today to talk about advertising fraud. Let me quickly introduce myself. My name is Art. I am an Android malware analyst on the Android security team at Google. We're going to be talking about advertising fraud and abuse today. This is something I'm very happy that you could join me to learn about this topic. We'll have a lot to cover in just a half an hour or 40 minutes or so, but I think you're going to learn a lot. So let's talk about first why we want to care about this topic. Adware is a very serious problem for both publishers, app producers, SDK providers. There are nefarious parties all throughout the ecosystem, and they will cause you much harm to your product or service. The adware can slow your device down. It can cause AV warnings from various vendors, including Google Play Protect. You can end up in the news with disruptive ads in your press coverage, something we've seen quite a bit of lately. And of course, you don't want to lose the trust or confidence of your users or marketers or any type of partner in the ecosystem. So it's something we really want to watch out for, regardless of where we are. We all have different roles as either defenders or programmers or analysts, and we can all do our part to fight adware. One thing that I notice quite often when I'm dealing with these big cases is that a lot of publishers end up working with nefarious SDK providers. And when the relationship begins, they really have no idea that they are working with a bad actor, and in fact, think that they're getting a really good value, high CPMs, or really good payouts for adding an SDK. And in reality, that SDK may be extremely harmful to them. And this is a very common problem. Avast released a press release earlier this year in March, and they stated that almost 3/4 of all of their detections related to adware in the year prior in 2019. We on the Google Play Protect team saw a similar thing. We first started detecting programmatic clicking, which is where fraudsters are faking ad conversions. And this is something we were very narrowly focused on, and it quickly became our most common warning. So it wasn't, it's pretty much everywhere in the Android ecosystem before we really started targeting it. And so you really want to make sure that you know what to look for and ensure that if you're going to add third-party code or any kind of advertising SDK to your app, that it's from a trustworthy source. And I'm going to give you some tips and tricks to learn how to really ensure that the code that you're adding to your app is not harmful to others. So hopefully I've convinced you that this really is an important topic, and it's something that we should pay close attention to as we get involved in advertising ecosystem on Android. So the first area of advertising fraud I want to talk to you is probably the most prevalent and the one that probably affects many of you the most, which is install attribution fraud. And what this type of fraud is where you are either paying for or being tricked into believing that an install of your app or one of your partner's apps was coming from a particular source, when in fact that source is just making up fake conversion data. And this is what it looks like really in the ecosystem, right? So we have an advertiser, they add an SDK to their app. And in theory, the ad shows and the user clicks on the ad takes them to the Play Store or maybe a third-party store, and then that install occurs, and then everything's normal, and you usually pay a sum for that conversion process. But what's happening with install attribution fraud is that a malicious SDK or some code that's running on the system is listening generally to a package added receiver, and they see a new package has been added, and they say, oh, well, is this a package that is a game or a popular app that might be on my network of advertising partners? If so, they can easily spoof the install information for that partner by using what's called the install refer API. This is a deprecated API that Google is recommending strongly that you not use anymore. But unfortunately, so many folks are still depending on install refer broadcasts for installations that the fraud continues to happen quite a bit. So this is what that API looks like. It's this very simple broadcast intent. Anyone can make this call. So even though it looks, as you can see from the text, that it's coming from the store, column Android vending, this intent can be broadcast by anyone. So it's an insecure means of broadcasting an install message. And it was convenient when it was created, but it has much outlived its usefulness. Although many advertising SDKs, attribution trackers, all kinds of various advertising partners are still using a listener for this particular broadcast, and they will use this as a valid install attribution mechanism. So what you want to do is check, is my install campaign dependent on a receiver for the install refer broadcast? If it is, you want to make sure that that is changed to the web API that Playstore provides. The HTTP refer API is much secure and is much less prevalent in the fraud space. So we want to ensure that these broadcasts are stopped and that you don't depend upon them anywhere in your code. And this happens way more than we would like. I've linked a blog here which you can view, where we talk about how we deprecated this API earlier in the year of 2020. Unfortunately, even after deprecation, many parties are still using this refer broadcast. It's something we definitely want to stop because, as I mentioned previously, anyone can just make this broadcast, and a lot of app publishers are paying quite a bit of money for what could be an organic install, no install at all. These broadcasts can come at any time. Generally, the fraudsters do try to listen to a real install with package added receiver to ensure that it maps up to a real user. This makes their fraud much harder to detect. But if we can just get rid of this outdated refer system, move to the HTTP API, we will avoid install attribution fraud at a great degree. And I hope that happens in the coming months. So let's move on to another topic that's also very, very common and a little bit more complex, and this is programmatic clicking. Programmatic clicking is where you use an Android API or JavaScript to fake ad conversions and either create an actual touch event or just send the conversion URL because you've cracked the pattern of the ad network's conversion scheme. So the former is more popular, where they actually just make a fake click. And there's a bunch of APIs that are generally, for the legitimate uses, tied to an on-click receiver. So maybe you have some out-of-scope function you need to dispatch when the user clicks on something. So you can use the dispatch touch event API to artificially register that touch. But you can also use it to create automated clicks or clicks that didn't occur on the real screen at all. And this is how most programmatic clicking fraud is done. Play Protect and many of the AVs have gotten much more aggressive at flagging this behavior, and we have seen a decline in it, but it continues to be very, very, very prevalent. Let's look at some code here. This code is an example of what you would see with programmatic clicking. The main clue here that this is an abuse and not regular use of the API is that the coordinates that are set up when the actual motion event is clicked are fabricated by the method itself. They don't register any type of receiver, and they don't receive any real coordinates. Again, in this case, the fraudster was very descriptive in their labels, and you can actually see that they have methods like delay click and that the auto click function is probably not something you want to see in your code. So this is what you want to watch out for. These random coordinates here close on the third line from the bottom. This is where you start seeing that the size of the ad is obtained and that they just randomly pick some X and Y coordinates. We at Google have gotten very good at detecting this type of programmatic clicking. It's something you really want to watch out for because it's a very serious form of fraud that costs a lot of people their trust in the advertising ecosystem. So we've been aggressively targeting it. So you want to avoid any advertising partner who thinks that it's okay to be cavalier with committing fraud in this matter. And you'd be surprised at how many large networks have this problem going on. So moving on, another thing that many of you are familiar with and something that we've been also clamping down on aggressively in the Android ecosystem is disruptive and annoying advertisements. This is where advertisements are popping out of the screen seemingly out of nowhere, right? You could be on the home screen, you could be using a different app like Maps or making a phone call, and then while you're doing this seemingly innocuous procedure, an interstitial ad will just seemingly pop out of nowhere. This is a very frustrating thing. We've gotten very aggressive in Android 10 and higher, where we're blocking a lot of these activities from the background now. So this is helping prevent interstitials from popping up. But for a large percentage of users are still on the 9 API or below, and they can see interstitials based on various system events. So this is a very simple procedure and easy to program. Really what you're doing here is you're just setting up a receiver that is tied to some kind of system event. It could even be a boot completed receiver. And then you generally set pending intent to fire ads, generally with an alarm manager. So you say, okay, after the boot completed receiver kicks off, I'm going to wait 60 minutes and then fire this method to show me an ad. And once that's set, that's just going to come from the background, right? Within that 60 minutes, the user could have, been closing your app. You have this background process that's running off of boot completed. Your app may have never even been interacted with, but yet it's causing ads from the background. This is a big problem for publishers because they adopt an SDK thinking that it's trustworthy, and then in reality, it just starts popping up these ads from the background. And this can be a real problem with testing too, because when you're using these types of techniques, you can set many server-side configurations to say, okay, well, we're going to start popping ads every hour, but to avoid people noticing this, we're going to wait 72 hours before the first time, right? So a lot of people might not even have the app installed for 72 hours. Certainly anyone who's testing an SDK isn't likely to keep the test running for 3 days. So they'll check your install time and call home and say, well, it's install time, not yet, not yet. Then a few days pass, and then all of a sudden, the ads start popping up in an annoying manner. This is a very effective technique because also, since so much time has passed from the user doesn't know where these ads are coming from, and they're probably not going to uninstall the app that's causing it. They're probably just going to continue to find this and find it very frustrating. They may even think that a more recently installed app was the actual cause. We also find that during this time, many of the adware applications are doing stuff like hiding themselves from the launcher or changing their title in the app's listing so that they look like a pre-installed or system app. We've seen apps using the Play Store icon or the settings icon to try to prevent attrition from users, so they don't really know how to uninstall it, and then it just keeps popping up. They're making revenue. The app itself is not really any type of useful app. It is just for really conveying these out-of-context ads, which are extremely frustrating and cause a really big problem with system performance. We also see with the disruptive ad space a lot of bad inventory, like you have a virus or very misleading system update notifications. And these are a big problem because as many ad networks try to clean their inventory, so many folks are able to dynamically swap their content at the last second and trick a lot of networks into, I'm sure many of you have all seen this when they clicked on the wrong ad, just an ad that's not actually what it says, but also can be like scareware or potentially like a fake ransom note or things like that. So just quickly recapping our whirlwind tour of our most common attributes of advertising fraud. So we went through programmatic clicking. This is a huge problem, causes advertisers a ton of lost revenue because they're paying for bots to click on things that no one really even sees. Disruptive advertising is a huge hit for the brand. Again, the conversion rates on these disruptive ads are very bad. A lot of this ends up being refunded because the user is not expecting to interact with an advertisement. So when the advertisement occurs, they're really just dismissing it quickly or accidentally clicking on it with absolutely no interest in the ad itself. So disruptive ads can cause not only a large amount of user frustration and a huge brand reputation hit, but they really hurt the advertisers themselves too, because the conversion rate is not very good for real interested parties. Install attribution fraud we went through. This is probably the most expensive and biggest problem that's happening right now. And we discussed quickly how to get rid of this problem, which is really that we all just want to deprecate that install refer broadcast API and make sure that we're not using install refer receivers. I suspect if many of you go to look at some apps with advertising packages that you have built or are maintaining, you will find in your manifest declared a install refer receiver. Check out why that's being done and try to get rid of that. You don't need it. You can use a more secure TLS request to a web server. You don't want to rely on the install attribution method. I think if there's one thing you want to definitely take away from this short talk is that install attribution fraud is probably happening to you or one of your large partners, and we can clean up a lot of it by getting rid of the insecure method of listening to refer to broadcasts. Another area which I'm probably not going to speak on because it's a whole another realm of its own is spoofing. And this is where people are using an SDK to lie to the programmatic advertising networks. They could pretend to be an iOS device when they're really an Android device. They could pretend to be in the US when they're in another geo. And what they're really trying to do is some kind of arbitrage scheme where they buy some inventory for an Android device and then try to sell it at the higher price for an iOS device, or they're trying to buy traffic in one region that may be a little bit cheaper and then sell it for in a much more inflated market that costs much more. We see all types of spoofing. I've seen even video ads, which they purchase the slot as a banner ad and then they ship a hidden video player and then sell the slot as a hidden video ad, where video ads are always much, much more expensive than static banner ads. So this is a very popular arbitrage scheme among people who can ship videos with pure JavaScript. So the important thing to realize here is that fraud only occurs when it's economically viable. And what we need to do as participants in the Android ecosystem is to really make it too expensive and hard and painful to really be successful trying to do advertising fraud. Unfortunately, that's not really the case right now. But as we all kind of work together and generate greater awareness of what the problem really is, I think that we can really start making this vertical a place where fraudsters don't want to come. And right now they're everywhere, but one of the reasons they are so successful is because they're able to get away with it because a lot of people just don't see what they're doing. We call this on the Android security team and a lot of other AV vendors cloaking. And what I mean by cloaking is that you're doing some type of nefarious behavior, but your app looks fine. And you might install it and use it, and it seems totally normal. But then after a little while, a new behavior starts to occur, or you install it in a different IP range or on a different type of device, and all of a sudden you get a whole totally different result. For example, Google Nexus and Pixel phones, many adware vendors avoid them because they assume that Google themselves use them, and they don't want to show Google behavior. They're a relatively small percentage of the marketplace, so it doesn't cost you much. I've seen malicious actors treat the entire West Coast of the United States differently than they do anywhere else, and also New York. And this is because many of the large companies are in these locations and they know that they're actually testing their apps. So when they test them from their home offices, they behave entirely differently. This may sound like some kind of like conspiracy, or that it's just so far-fetched that people would go to so much trouble. But when you really realize there's sometimes hundreds of millions, but usually at least millions of dollars on the line. So it actually just makes perfect good business sense for these fraudsters to create these elaborate evasion schemes. And many of them are actually much better than some of the malware botnets that we see who are maybe just doing phishing or Trojanizing apps. Many of the adware companies have a lot more resources and have a lot greater financial motivation to really do really successful and complicated cloaking techniques. But generally speaking, across malware and adware, most cloaking just follows a similar pattern, which is that you're going to set up a command and control infrastructure, and that is going to be contacted by your app. And during the installation of an app, you want to ensure that you collect two main things, which is an install token, meaning I want to track that specific, give an ID to that specific install, but I also want to create some kind of system unique identifier so I can ensure that if that same phone installs again, I can watch that it's installed multiple install sessions. So you have a unique install ID, and then you create a unique ID based off some kind of physical attribute or system attribute of the device that's not easy to change. Maybe you use the MAC address, maybe you use some fingerprinting of some serial numbers or the CPU. This can be done in a very large number of ways, right? And once you gather this information, you make decisions on your back end on what you're going to serve them. So, for example, let's say that you're a publisher or of a large app, like a large dating app, and some SDK provider comes to you. They may say, oh, you know, this company who's producing this app, they have their own NetBlock on Aaron, so we're going to blacklist that NetBlock. And when a request comes into that NetBlock, we're going to say, okay, we're going to serve them a different experience than we are from a real world user. As I say, this may sound extremely complicated or conspiratorial, but it's actually just everyday behavior for large adware vendors. Many times they also are checking if you're using a VPN or if you're testing in some kind of emulator or cloud provider. I've seen checks that if you notice a lot of profiling of the system inside of an SDK, be very suspicious of that profiling and try to figure out what that profiling is doing, because that profiling may be putting you on some kind of block list in order to ensure that you don't see the bad behavior. Because if you're compliance analysts or engineers, whoever gives the okay to add an SDK to a large app, see that the SDK behaves cleanly, they're probably going to give it the green light. But then once it's out in the wild, the behavior can change drastically. And this is how most of the largest fraudsters succeed in their mission of making lots of money. So some tips to ensure that you really see the real behavior of a potentially nefarious SDK. Make sure that you do at least a little bit of testing of an SDK on a real device and not just on the emulator. An emulator is extremely easy to detect. It has a different CPU. Most emulators are run on x86 systems, and they will see the ARM translator in one of the system properties and determine that you are an emulator because of that. Oftentimes, nefarious behavior is avoided on free installs, right? Analysts are always just installing the APK, sideloading it, downloading it from VirusTotal, testing it. This is much different than when someone pays for an ad to show up and the install occurs through the install flow we discussed earlier, like through clicking on an ad and going to the Play Store. That's going to generate some type of referrer and campaign tracking information. So one very common technique that I see a lot is people using that referrer information, which can't really be guessed by an analyst, to only target users with the proper information to show, hey, this is a user I paid for, so I'm going to try to get a high return on my investment. If I'm a user who just installs for free, there's no risk for me to not really get my, the maximum revenue from that user. I can just get the normal behavior. And you'd be surprised, many of these like seeming innocuous flashlight apps or compass apps or QR code scanners, they seem so normal at first, but then when you don't have a particular string in your manufacturer of your phone, or if the CPU is not a Goldfish, which is the emulator CPU, you'll see that it's downloading different payloads, or it is throwing up advertisements, whereas these mechanisms are essentially dead code on test devices. So make sure that you are trying to get your apps from the wild if possible, install them for real, let them sit for a while, just leave the test device alone, come back, make sure that your install time is a reasonable period. And then you're much more likely to see real behaviors on a phone. Another thing that's very popular among adware companies is they avoid entire autonomous system numbers, which you can easily acquire from Aaron or other internet registries around the world. And so these net blocks for Google, Amazon, Azure, many AV vendors, many VPN providers, they're easily found and well documented by bad actors. So make sure you're not doing some kind of cloud testing or routing through a common VPN provider, because that's almost certainly you get caught. Again, your experience is going to differ really based on your vertical and what people are trying to do. But the most common thing is that they're going to start showing disruptive ads with their SDK, and that's why they can afford to pay you a higher CPM or, what looks like a ridiculous payout for an ad SDK. Be very wary of any provider who comes to you with some type of information that, above market rates and they're some no-name company you've never heard of, this is probably because they can afford to pay this because they're doing some type of scheme with your users where the payouts can be so high because the majority of the payouts that they're receiving are fraudulent. So the problem with accepting SDKs like this is that your app may get caught up in the scheme, and analysts, researchers, AV vendors may think that your company is responsible. It's very hard to detangle yourself from nefarious parties who are committing fraud using your app on your behalf. So very important to avoid this type of thing. Hopefully this tour was something that got you at least more interested in advertising fraud. I think that we've taken up a pretty good amount of time. So I'm gonna stop here and see if we have any questions available and go from there. Well, I'm not seeing anything come in, but you can reach me at artk@Google if you ever want to reach out in the future or have questions about advertising fraud. I will be happy to reach out to you. Thank you so much for attending, and I hope you all have a great time at droidCon. Thank you so much.